Okay, let's get started. Hi, everyone. It's great to be back with the GDC community. I'm Ke, and I'm joined today by my colleagues, David and Hogan, from the product and engineering teams of PICO. So if you have been following our news, you know that we just unveiled our next flagship device, Project Swan, and the brand new PICO OS 6 that it runs on. Today, we are going to recap our recent develop launch event and talk specifically to you, game devs. And we will show you why Project Swan is the perfect home for your work and how exactly you can bring your apps and games in to this new platform. First, a quick intro for those new to us. By a show of hands, how many of you here are hearing about PICO for the very first time? Okay, thank you. Now, how many of you have actually used a PICO headset? Good, thank you. And how many of you have already developed for our platform? Great, thanks for sharing. To give you some context, over the last decade, we've launched 10 XR headsets and 5 major OS generations. We are bringing millions of people around the world into the world of XR. Today, we are here to show you the blueprint for the next chapter. Project Swan is our next generation flagship device, designed with the goal of breaking through some fundamental bottlenecks in XR user experience. 3 years in the making, PICO Silicon for mixed reality is our custom designed chip for Project Swan. It addresses the complex pipeline from real-time sensing, spatial computing, to image processing and display. With a crazy 12 millisecond end-to-end latency, it delivers an MR experience that's incredibly stable and natural. Project Swan has a unique dual-chip architecture. PICO Silicon works in harmony with a flagship SoC to drive a dual-eye 4K experience. Compared to the current X2 Gen 2, the SoC delivers more than double the performance in CPU and GPU. We also customized a new generation of micro OLED display, achieving 4,000 ppi, which is more than 9 times the pixel density of the latest smartphones, making Project Swan a viable alternative to physical monitors. And of course, your games will run bigger, sharper, and smoother than ever before. While we are in the final stage of delivering Project Swan for a global launch later this year, however, developers can build with us today with PICO OS 6, the new operating system exclusive to Project Swan. PICO OS 6 brings a new era of XR, which we believe is general computing. Much like desktop experience for gaming, imagine that you can now achieve actual spatial multitasking while playing games in XR. For example, you can watch big screen videos while playing tabletop games like this. Or view the same spatial content and chat with your friends while playing the game on your physical desk at the same time. These multi-app experiences were made possible by our new PICO Spatial engine, which reconstructed the rendering pipeline from the app level down to the OS level to support running multiple 2D and 3D apps through a unified rendering architecture. In this new architecture, each app submits its rendering to the spatial engine, which does the composition for these apps, integrates systems experience while handling performance optimization, and also the physics, input, interaction, animation, etc., before presenting everything onto your screen. For developers, the engine delivers a comprehensive set of powerful capabilities, including interaction, physics, mixed reality, spatial video and audio, and graphics features such as animation, light and shadow, particle system, and shader graph. It's built on ECS, which many of you are familiar with, a modern app development framework that ensures long-term extensibility. PICO OS 6 supports multimodal interactions. If you're browsing content, you can simply use eye tracking or gaze pinch. When you want to play games, grab our XR controllers or wear the PICO motion trackers for a more embodied presence. We also support keyboard and mouse for productivity use cases. This is a breakthrough for people building spatial apps because for years, many users have been forced to learn not the most efficient interaction in XR, and developers either build for lean-back entertainment or lean-forward work. But now the interactions adapt to you, not the other way around. In summary, for game developers, we believe Project Swan and the new PICO OS 6 will deliver the best-in-class XR gaming experience. It comes with the PICO silicon that features a very low latency, 12 milliseconds for mixed reality pipeline. It has the dual-eye 4K micro OLED display with clarity good enough to be a viable alternative of your physical monitor. It has the dual-chip architecture that delivers double the performance in CPU and GPU than the previous generation. And then the OS enables true spatial multitasking. It supports both immersive and multi-app experiences. Building an open ecosystem for XR is what we believe the best that serves the developers in the industry. Your existing Android apps will run out of box without reprogramming. You can simply open an Android APK to run in the shared space on PICO OS 6. We provide enhanced support for open standards such as OpenXR and WebXR. Your previous standalone or PC VR games will run even better with Project Swan's 4K displays and stronger rendering power. Besides the fully immersive experiences, we also support building apps and games that leverage the shared space. And today, we're looking into that in more detail. But here's the thing, no matter which tech stack your team relies on, native app development, web development, or game engine, we provide the tools for you to build with ease. Let's do a quick survey. How many of you have created a game using native Android development? Okay, cool. And how about building games with web tech stack? Cool, thank you. And how many of you have created games with game engines such as Unity and Unreal? Okay, wonderful. So currently, Android doesn't have a built-in 3D engine for building XR app natively. That's one of the reasons that we have built our PICO Spatial Engine and the PICO Spatial SDK to support multi-app experiences in the shared space and building natively in Android Studio. PICO Spatial SDK uses Kotlin as the programming language and integrates all the engine's capabilities that you saw in the previous slides. It comes with the declarative UI framework, PICO Spatial UI, which simplifies native UI development for spatial apps. It comes with a component library and ready-to-use Figma assets, letting you focus on creativity, not complexity. The UI materials will adapt automatically to different lighting at the runtime, saving your cost for environment-specific UI tuning. The PICO Spatial SDK also comes with handy tools, including the PICO Spatial plugin and the PICO Spatial editor. It enables developers to easily build 3D XR games natively within Android Studio. And the best part is you don't even need a device. You can build, test, and iterate fast in our PICO Emulator. And all the SDKs, dots, and tools are all available now for you to start with. Besides the PICO Spatial SDK and its tools, we also upgrade our game engine SDKs to serve a wider range of game developers. We think there could be three main categories. First is existing game developers using OpenXR for cross-platform development. We always support OpenXR and have refactored our SDKs to use OpenXR APIs to the best of our effort. With Project Swan, you can create games with stronger performance and higher fidelity than on other platforms and release more resources if you need to port your game to Project Swan. Secondly, we also enhance the SDK's capabilities for developers to build shared space experiences, where your game can run together with other apps or some companion apps. And we make it very easy to convert a full space game to a shared space game. last but not the least, we think for mobile game developers, you can try porting and adapting your game to this spatial platform, much like how you'd use a PC to reconstruct a mobile gaming experience. We hope to inspire you to add unique spatial elements to your original game for more possibilities. And next, my colleague David and Hogan will walk you through how to use these SDKs.
Thank you, Ka. Hello, my name is David Campos Rodriguez. I am a software engineer at PICO. As we have seen, PICO OS 6 offers a wide variety of ways to create your games, whether it is directly through OpenXR, using popular commercial engines like Unity or Unreal, with web technologies, or with direct access to the capabilities of the OS through the PICO Spatial SDK. Let's take a look first at what the Spatial SDK has to offer. For this demo, I will use one of the examples that you can find in our developer documentation. It is a very simple example that one can build up in a couple of hours. And it will be a live demo, so anything can happen. And we could just play some video and talk over it, but that would not be fun, right? So, as an introduction, in PICO OS 6, each activity in your app corresponds to a container around you in your 3D space. And these containers can be of different types. For example, we have the window containers, which show up in your space alongside other window containers, and they can be either planar or volumetric. And we also have stages, which allow apps to leave this shared space and go into the full space around your user for a more focused experience. In this case, we are using a volumetric one. And I think that volumetric containers are great for cozy or casual games, because you can imagine playing these games alongside a music player that is playing in the background and having a chat with your friends on the side. And we can easily configure all the container options associated to an activity in the activity declaration in the Android manifest. For the contents of the app, we use Spatial UI, as my colleague introduced. Spatial UI is the UI module within a Spatial SDK, and it is based on Jetpack Compose. It provides a fully reactive and intuitive way to create your visuals for your app. And there are a bunch of 2D composables that we have designed at PICO, especially for PICO OS 6, that you can take advantage of, like buttons, sliders, the typical. But of course, you are not constrained to the ones that we created, and you can create your own UI elements to add to your app. To incorporate 3D contents into the windows, Spatial SDK provides two different kind of composables. On one hand, you have the spatial model view, which allows you to very easily load 3D models into your windows. And on the other hand, you have a spatial view, which is more suitable to take full advantage of the ECS capabilities of the engine. And that's the one we would use. So now let's try the demo. Let me switch here. So sometimes when developing, you will not have your device available, or it may not be practical to be switching back and forth between your host computer and the device you are developing on. And so for that reason, we have created the PICO Emulator, which you can see here. The PICO Emulator simulates the device on your computer, and it will run your app in the exact same way as it runs on Project Swan. So you can rely on this to develop your app. It also offers some other features. For example, you can change the environment, which will allow you to see what your app will look like in different lighting conditions in the real world. And as you can see, I have here the sample already running. Let me move down. It's a very simple sample. It just has a few dominoes, and when you tap on one of them, they fall down and they change color. So how would we go about adding a new element to this scene? Of course, we could load a model from file, like through some code, and add it to the scene, to our spatial view. But that is really not very intuitive. And constructing 3D scenes just by writing a bunch of code or adjusting numbers here and there is not the best way to construct 3D scenes in general. So that is the reason why we have created the PICO Spatial Editor. The PICO Spatial Editor allows you to add entities, remove entities, components, but even much more. You can create your custom materials with shader graph. You can also create timelines, which is right now in beta, and analyze the statistics of your game, many things. So let's try to add a model here to our scene. Luckily, somebody left a model ready here for us to add to the scene. So I can pull it here, and in a second, I can use the tools from the editor to just put the model right in place. Let me move this up a bit and place it more or less there. And maybe let's add a collision component, which basically will make our model a static collider, so it can stop the dominoes. Let's quickly rerun this app. And so when you build the app, the spatial editor will get invoked to bundle all the models in your scene into your app. And so when we rerun, here we have the robot cleaner, and it's actually a static collider. But I know what you're thinking. You probably are thinking, I have a robot cleaner at home, and that's not how robot cleaners behave, right? In reality, it's a well-known fact that robot cleaners immediately explode when contacted by domino pieces. So we could do that with a custom component and system. I have some prepared here. So if I go to the project in Android Studio, I have here a bunch of code commented to add this component and system. As you can see, creating components is very simple. In this case, I'm creating an explosion component with a should explode Boolean. And then I create a custom system that will check for these components. And when set to true, it will basically perform a little replacement of the entity so it looks like an explosion. Of course, we need to set this Boolean to true. And to set it to true, we can, in this project, go to the collision manager, which is the one handling the collisions. And every time two entities collide, we can check if any of them has the explosion component. And if they do, we set the should explode to true. And finally, every time you have custom components or custom systems, you need to remember to register them with the Spatial SDK. So for the systems, the Spatial SDK will know about them. And for the components, it will be able to resolve them at runtime. So now we have to add it to our vacuum cleaner. And one cool thing about using the spatial editor is that just by adding the component class to your project, the spatial editor will detect it and add it to its interface, so you can add it here. In this case, we didn't have any serializable property, but if we had them, they would show up here. And with this, the demo should be ready, so we can rerun. It should take a bit longer because now it has to recompile. But if everything goes right, this should work. Let's take a look. Moment of truth. How many of you think this is going to work? Let's see. Oh, I put the collider too close, so it just detected the collision before falling. Yeah, but that's Spatial SDK. And if I go back here and switch to, oh, it switches automatically. Okay. So the PICO Spatial Editor and the PICO Emulator can be downloaded directly from the PICO Spatial plugin for Android Studio. And with the PICO Spatial SDK, the Spatial Editor, and the PICO Emulator, it's very easy to create any kind of XR games and XR experiences. And so I cannot wait to see what you all create with these tools. But that is not all. The incredible teams at PICO have been working hard to provide you with so many SDKs and different tools to create your games. And now, my colleague Hogan will introduce you to the PICO Spatial SDK for Unity.
Hi, everyone. My name is Hogan. I'm also a software engineer at PICO, and I will be introducing you to PICO Spatial for Unity. So just based off of the show of hands at the beginning of the talk with Ke, it seems like a lot of you guys are already acquainted, at least, with PICO, probably existing XR developers. Some of you guys are well immersed in the community, I'm sure. I'm seeing some SVVR people here, so 100%. This means that probably a lot of you guys are familiar with PICO Unity SDK, which is our proprietary SDK that is a Unity plugin that allows you to develop specifically for PICO devices. Additionally, on top of that, PICO OS fully supports OpenXR, which is the open standard for XR applications. This means that using, for instance, Unity's own OpenXR plugin, you can build an OpenXR app within Unity and expect it to run on any PICO device, as well as across a wide array of other devices from other vendors. And on top of that, we're proud to announce PICO Spatial for Unity, which is a new addition to the Unity ecosystem. So PICO Spatial for Unity provides a bridge between Unity Engine and PICO Spatial Engine. Through PICO Spatial for Unity, existing Unity developers will be able to take their Unity project and create a spatial app on PICO OS 6. A Unity app built with PICO Spatial for Unity will see its UI, particles, meshes, materials, sprites, and much more replicated and fully rendered within PICO Spatial Engine. On top of that, because PICO Spatial for Unity still runs on Unity Engine, you will maintain access to the same library of plugins, features, assets as any other Unity app. And AI, physics, animators, and game simulation scripts will all behave the exact same way as a standard XR Unity app. And also, we should mention that PICO Spatial for Unity does leverage Unity's existing XR ecosystem, which includes AR Foundation, XR Hands, XR Interaction Toolkit, and XR Core. Now, to better understand the capabilities offered by PICO Spatial for Unity, let's take a look at this game. It's called Desktop Clash. It's a tabletop tower defense game that was developed by our in-house developers. And it was originally a fully immersive XR experience built on top of PICO Unity SDK. It leveraged mixed reality for added immersion, such as hand tracking for picking up and placing towers, and video see-through to ground the scene with your real-world environment. We should also mention that all of these features are available through OpenXR, so this app that you could see on the left-hand side could fully just as well have been an OpenXR app built on Unity OpenXR plugin. And then on the right, you could see what the final product looks like after our porting process to PICO Spatial for Unity. Isn't it really similar? And you could probably also see in the background, we have a bunch of other apps open at the same time, and this is just one huge perk of building using PICO Spatial for Unity is it could function as a spatial app within shared space on PICO OS 6. Now, diving into the weeds of what went down in our porting process, let's start with the conversion of assets, which was relatively easy and straightforward. This is because included in PICO Spatial for Unity is a comprehensive asset conversion layer, which translates compatible assets from Unity Engine to PICO Spatial Engine. This conversion layer supports a wide array of Unity renderers, including meshes, skin meshes, sprites, particles, and canvas elements, such as images and text. It also supports a wide array of shaders, including URP, standard, particle, mobile, and in a future release, shader graph shaders. If an asset does happen to be inconvertible, for instance, a material that utilizes an unsupported shader type, then we will get a warning when we try building our PICO Spatial app. And we encountered this a couple times throughout the development process, and simply just by taking the materials that were using an unsupported shader and switching over to a supported shader, we were able to get like a pretty seamless working result in the end. Besides that, we need to translate over a lot of our particle systems, and this is because the particle systems in Unity Engine are not necessarily one-to-one with the particle components built on top of the particle ECS in PICO Spatial Engine. And so that means that we need to spend some time sort of digging in and fine-tuning particle parameters to ensure that the proper effect was conveyed in the end. Now, when porting over Desktop Clash, we wanted it to work in shared space so that you could have other apps open at the same time for maximal productivity or brain rot, whatnot. And to achieve this, we added a spatial camera, which defines which portion of your Unity scene is visible at any given time. In shared space, PICO Spatial Engine will only ever render the portion of your scene that fits within the bounds of the spatial camera. So it's necessary to add one, but if you forget to add one, we will automatically add one. So the original Desktop Clash, like I mentioned before, it leveraged XStar hands and hand tracking to interact with the entire scene. Now, unfortunately, with shared space apps, they don't necessarily have access to all the hand tracking data that full space apps do. And so we need to find a way to get around this. So we leveraged a custom input scheme built for PICO Spatial for Unity called Spatial Input. With spatial input, it combines the best parts of XR input subsystem and Unity touch input, allowing support for full multimodal interaction, including hand gaze interaction, keyboard mouse interaction, and controller interaction. So all the three kinds that Ke brought up earlier. Now, I want to note that spatial input is more akin to a touchscreen interaction under the hood than standard XR interaction styles. So the consequence of this is that it may actually be a lot more easier to translate input interaction code for a standard 3D mobile game than interaction code from an existing XR app. Spatial input is also fully integratable with XR interaction toolkit, which means that you could just like add an action map on top of your existing input action map and expect everything to sort of work. Now, let's see Desktop Clash in the flesh. We do have another live demo, so also wish me luck with this one. Let me close out this app. Okay, so I'm gonna showcase a feature included in PICO Spatial for Unity called Play to PICO, which helps a lot with the iterative workflow of PICO Spatial for Unity. By opening up a specific app in your PICO device or PICO emulator, you're able to host a live session from a Unity editor that's connected to your device. And this works over both LAN or USB connections. And in fact, it's a lot, it just makes the entire process of making changes to your existing project and then seeing it viewed on your PICO device live, it makes it like a very smooth experience. So as you could see on the right, we have, So yes, now you can see everything going on. So as you can see on the right, we have the live Unity editor session open, hosting Desktop Clash, and we can interact with the level on the left by moving around the tower, and all of the input events occurring on PICO Emulator end up getting sent back to Unity Editor for full simulation. And you can see the tower being moved around, and essentially the two engines are now in sync on the same device. Now going back to the slideshow. If you're interested in more details about Desktop Clash, we will be releasing it fully open source, both as a fully immersive XR experience and a PICO Spatial for Unity app. Now, I want to touch on a couple things that you might want to consider during the process of considering if you want to take your existing Unity XR app and take it into the spatial medium or not. So first off, because with PICO Spatial for Unity apps, we are running two game engines side by side, you should expect a decent overhead from having those two engines running side by side than having one at a time. For instance, with a standard spatial app like David showcased, or a fully immersive OpenXR style app. If you have something like a FPS that expects super high fidelity simulation and frame rate, then this may not be the best medium for that. But that does not mean that Swan is not meant for you, because you could take full advantage of the improved hardware, 4K resolution, and more powerful chipset, like we mentioned before, to make your existing fully immersive XR experiences to the next level. Next, how does your art style translate in PICO Spatial Engine? You can see in the video that's playing on screen that we don't necessarily have the one-to-one rendering engine between the two Unity engine and PICO Spatial Engine. So this is something that you should be considering, like how do all of your individual assets look like in PICO Spatial Engine specifically. But over time, we're working tirelessly to bridge the gap between the visual effects on both engines. And this means, for instance, like we mentioned before, future support for Shadegraph, which will allow you to take and implement custom art styles like cell shading within PICO Spatial Engine. And on top of that, a lot of the issues that I mentioned before about converting over particles will get minimized over time as we make the process of converting particles more and more seamless, supporting more and more modules over time. In spite of these concerns, I do want to highlight some of the prime use cases for PICO Spatial for Unity. First off, we should expect that apps similar to Desktop Clash will be readily portable in PICO Spatial for Unity, specifically tabletop games like you could see. And then on top of that, more slower paced games like turn-based games or cozy games will work perfectly in the spatial medium. Additionally, as mentioned before, shared app experiences utilize an input scheme more akin to mobile experiences, meaning that you could probably just take your existing 3D Unity project that was built for mobile originally and port it over to a shared space experience. And it'll be an extremely easy process. And then we mentioned before how PICO Spatial for Unity supports XR hands. If you have an MR experience that interacts with everything through hands specifically, then you can expect that everything should work out of the box for full space experiences in PICO Spatial for Unity. Overall, we do strongly believe that PICO Spatial for Unity greatly expands the realm of what's possible. It provides a launchpad for existing Unity developers interested in the future of XR. For more updates on PICO Spatial for Unity, PICO Spatial SDK, and all things spatial, join our PICO Developer Discord or follow us on social media. And then we also want to shout out, we're having a hackathon this weekend with Sense AI called the Worlds in Action. And it's in partnership with XR Bootcamp. And we will be there and helping you along the way. You'll get hands-on experience with PICO, and it'll just be cool in general. To learn more about our updates and programs, visit developer.picoxr.com. And thank you so much. Oh, and also just a reminder to fill out the survey that'll be sent out at the end. Yeah, thank you. Now time to open it up to questions.
I have a question about, I want to know whether or not that people can get the spatial data from the room, just like if I wear the Pico, I know there's some collision, some object in there, and or I can shoot some bullets to there and it get some collision to the real object. I want to know if or not the Unity plane job for Pico can achieve that.
So the question that was asked was, what are the mixed reality capabilities offered in Pico OS 6?
Yeah.
Sorry. And I think that there was two questions in that. First off, with the shared space and full space modes, what MR features are supported, and then the other one was with PICO Spatial for Unity, what MR experiences are supported. So we do support things like that. And I think that we have a full list of features in our developer documentation about specifically which mixed reality features are offered. And they are offered both through AR Foundation and Unity and through Spatial SDK, through certain ECS components and systems.
Okay, thank you.
Yeah.
Hi, I'm very excited about Project Swan.
Thank you.
And I actually have some questions. So I'm making tabletop games for mixed reality. And camera access is something we want to work with. And I was wondering if Swan will have camera access. And alongside that, will we have fiducial tag tracking, like supported natively on the SDK or somewhere?
Yes, we do currently support hand tracking natively through the SDK. It's already available on Pico 4 Ultra.
Sorry, not hand tracking, tag tracking, like April tags tracking. Like you have like a sticker somewhere that has like a QR code kind of, and like follows it, basically.
So we don't have the tag tracking right now in the SDK, but it will be added soon. And the other question was about
Camera access.
Camera access. So we provide full camera access actually in our own secure environment. We call it, well, it's Secure MR was in Pico, in the previous Pico, and now it's a Spatial Secure MR. That provides full camera access, and it has some warranties. Actually, it gives you more than just camera access.
Nice.
Because it's a safe environment that requires some permissions ahead. And so we can give you, well, access to the MPU and run your own models there. And you can even synchronize information back to the app if you don't want to just render based on that. So yeah, you have that available.
Awesome, thank you.
Yeah, just to add to that, if you run the location-based entertainment facility, our enterprise solution also provides very rich support for the tags and QR codes.
Okay, awesome, thank you.
I noticed that you mentioned select MR experiences, but can you please expand more of like what use cases, trends that you are seeing for mixed reality VR apps for PICO?
So you're talking just from a BD perspective?
Yeah, because
what
I'm
we
a
foresee.
VR developer.
Yeah, we actually have a couple members from our developer ecosystem team here to who are probably a lot better answers of that question. Yeah, but We have Rick over here, and then David. So yes, after the talk, it's definitely like a good thing to bring up with him.
Okay.
All right, if that's all for questions, then I want to thank you guys so much for attending, and then also, again, make sure to fill out the evaluation form at the end of this talk. Yeah, thank you.
Thank you.